Welcome back, further maths students, to this next video. In it, we're going to be looking at using our recurrence relation that we looked at in 9A. That was the one that combined R and D in the same recurrence relation. This time, though, we want to look at what context would we use one of these recurrence relations. And I mentioned we're going to use it for reducing balance loans. So these are compound interest loans, and it's where we're going to be looking at paying back the loan. So in other words, you borrow the money, but then regularly you start to make payments on that loan, and eventually you're going to hopefully pay off that loan. Now you're going to be charged interest along the way, but since that interest is compound, that means that that over time you owe less money, and so over time you have less interest being charged. So the interest will be charged regularly, so we call that the compounding period. That could be monthly, it could be fortnightly, it could be even less frequent, so it could be quarterly, say. And when you come across that compounding period, so say you come to the end of the month or the end of the fortnight, end of the quarter, you will make a repayment as well. So we're going to see interest being charged, but also a repayment being made. Now what happens is the repayment, it should be a little bit more than what the interest is at the start, and by the end of the loan we should see the interest quite small. So the repayment should reflect really the compounding rate that you're seeing, but also the amount that you're borrowing, so it should be in proportion to that. And what happens is a part of that payment will go to paying off the interest to start off with, and then the rest of it will go towards paying off the actual loan, so reducing the amount that you owe. So just a final point, that since the amount that you're owing is continually decreasing and that the interest is calculated on that balance, the amount of your interest will decrease throughout the term of that loan. So it sounds a little bit confusing at first, but what we're going to do is just focus in this video on the recurrence relation. In the next video, we'll look at something called an amortization table, so that we can see, I guess, more clearly what is happening payment by payment with these loans. So to the recurrence relation now, we've got V0 is our principal, so that's the amount that we borrowed at the beginning. And to get the next term, we're going to multiply by R. In this case, capital R is 1 plus R over 100, and that's because this part here, this capital R, represents interest being added on. So it is a percentage, of course, and so that's why we use 1 plus R over 100. Just like when we were doing compound interest earlier in this topic, it is per compounding period. So if it's quarterly, you're going to have to divide that per annum rate by 4. If it's monthly, divide by 12, fortnightly, divide by 26, etc. This bit here, you'll see down here, is defined. It's the payment being made. So what's happening here is we're going to multiply by R, which is greater than 1, as you can see. That's going to make our next value a little bit bigger, but then we're going to make a repayment on that loan. So it's going to wipe out that extra bit that was added, but also take a little bit off of the loan. Our new value in our sequence should be less, because we want to be paying off this loan, so we should see the values decrease, but it's decreasing a bit differently to what we've seen in geometric decay examples so far. Let's have a look at some examples so we can see it in practice. We've got Paul wanting to buy a road bike, and so he's taken out this loan of $10,000. That's at 6 years. I'll just mark that as V0 since that's the original loan. It's 6 years he's going to borrow the money for, and the rate is at 8% per annum. Now it says here interest debited quarterly. That is another way of saying that it compounds quarterly. So I'll just make a note of that. And then he's going to pay back quarterly as well. Now what you'll notice is that will be true of the ones that we come across. If you see that it's compounding quarterly, you should have a quarterly payment as well. If it's compounding monthly, monthly payment, etc. That should match, in other words. Installments are $528.71. So that's our D value. That's in our rule up here, the payment that's being made. Just before I start though, see how this is per annum and it's quarterly? That means I need to divide this, 8 divided by 4, so we get a rate of 2 or 2%. I needed to do that first because I want to get my capital R value if I'm to write a recurrence relation. So it's going to be 1 plus 2%, giving me 1.02. Now I can write my recurrence relation because I've got original value borrowed. To get the next term, I do 1.02, that's my R, that's representing 2% interest is added on, but then Paul makes a payment of 528.71. The reason that it's being subtracted is that this is being subtracted from what he owes. This here is always telling us what Paul owes at any given time. He owes the most at the beginning, $10,000, but then 2% will be added to what he owes, and then 528.71 will be subtracted from what he owes. Let's have a look at what it looks like with the calculator because we need to create this table or complete this table. We've got N, which is repayments, and we've got VN, balance of that loan. Now, before any repayments are made, he owes $10,000, so we can put that one in straight away. I'm going to go to my calculator now so that we can get or can generate these terms for VN. Let's get 10,000 in, that's V0, and then let's enter in the recurrence relation, which looks like this, 528.71. Okay, so that is V1, so after one payment, V2, 3, and then V4, which is the one we needed to go to. With these, we'll of course round to 2 decimal places each time. So you'll see this one's going to become 0.19, 0.02, 0.01, and that one's obviously just 0.29. I'm going to enter them into the table now. So I had 9671.29, 9336, that was rounded to 0.01, 8994, that was rounded to 0.02, and the final one, 8645.19, that was rounded as well. Finally, we're just going to investigate a little bit about the interest really in this scenario, because we're asked to explain why has Paul not reduced the amount he owes by this amount, by $2,114.84. So that's actually what he has paid back after 4 quarters, because he paid 4 payments of $528.71. So that's where this 2114.84 has come from. He paid them that. However, if we have a look over here, the amount owing right now is 8645.19. Keep in mind that he borrowed the $10,000. He borrowed this, and after 4 quarters, he owes this down here. I want to have a look at how much has he paid off the loan. So how much, really, between 10,000 and 8645. So he's reduced the loan by 10,000 minus 8645.19. And that gives us 1354.81. So there's a discrepancy here. He's paid them back $2,114, but he's only reduced the loan by 1354. And we want to explain why is there that big difference. What's happened, of course, if we have a look up here, is this 8% per annum interest that Paul has been charged. So every time he paid back $528, $528.71, not all of that was coming off the loan. A portion of that was paying the interest that he was being charged, which was 2% per payment. portion of that 528 pays off that 2% interest. The rest of it goes to paying off the actual loan. So as a result, he hasn't paid back off the loan $2,114 because he has paid interest in that time. It's because part of every payment just write that out. Part of every payment pays the interest first. Then the remainder pays off the loan or reduces the loan. So that's one way that we can actually calculate interest as well, because we can look at the difference between how much he's paid back and how much he's reduced off the loan, and the difference between them must represent the amount that has gone towards interest. Just another example, just so we get a little more familiar, another 2 examples in fact. We've had to create a recurrence relation, but also just looking a little more in depth at what's going on. In this one, Noah takes out a personal loan of $2,000, so there's our V0. It doesn't matter what he's buying here, that's not going to change what we do, but with the loan having an interest rate of 12% per annum. It says here he'll repay the loan with 8 equal monthly repayments, so monthly. That means I take this rate and I divide it by 12, so we get 1% per month. Here's our D value because that's the amount that he is paying back. Let's get our capital R, 1 plus, oops, I've just put the plus instead of equals. 1 plus 1%, giving us 1.01. B0 is $2,000, and to get the next term, we're first multiplying by 1.01, and then we're going to take away the payment being made, which is $261. We're asked then to use this recurrence relation to get how much is still owing after 4 payments or 4 months. So I'll just delete the one that we used previous and create the recurrence relation. 2,000 goes in, and then 1.01 times by our answer, and then take away 261. We want after 4 months, so here's after 1 month, after 2, after 3, and then after 4. We get 1,021.44. And I'll just label that as V4. Now keep in mind, we were told that it was going to take 8 monthly payments, but what sometimes happens because of rounding off is we might have a tiny little bit left over at the end of the 8 months, and that's what this is getting us to explore. Is the loan paid out exactly after 8 months? And if not, how much will Noah need to add to that last payment to make sure that it is fully repaid after the 8 months? So what I'm going to do is just keep going with my sequence. That was after 4 months, after 5, 6, 7, and then after 8. As you can see, after 8 months, we actually have $3 left over, or $3.15 when rounded, left over. Now, Noah can leave that if he wants for another month, but he will be charged 1% interest on it, 1% for the month. So it's best that, since it's just a tiny little bit, that is just added to the previous payment. So if we go back just to... He has not fully repaid it after those 8 months. So Noah will need to pay an extra $3.15. And that's with that last payment. Okay, so one more to have a look at. Gail has agreed to pay a much bigger loan this time, $74,000, so V0, and she's going to pay it back with fortnightly installments. Here's the fortnightly installment or payment, $323.73, and that's over a 20-year period, so a really long loan this time. Now, the interest is really high, 9.75% per annum. It's adjusted fortnightly. Remember, that means compounded fortnightly. And so what we'll have to do here is divide by 26. So I'll just this bit here, 9.75 divided by 26, and we get 0.375. Remember, we don't round that off. We want to keep it all the decimal places that come up. So R is going to be 1 plus our 9.75 on 26, or 0.375, since we just calculated it before. That gives us 1.00375 as our capital R value. Our V0 is $74,000, and Vn plus 1, R times Vn. And we've got our D value up there, so we just bring that down, 323.73. Okay, so what we're asked next is, what's this interest charged before the first repayment? Keep in mind, before the first repayment, owing is $74,000. And the way that a reducing balance loan works is that you are paying your fortnightly rate of interest, which in this case is 0.375%. And you're going to be charged that interest on what you owe. So just quickly, what I need to find here is the percentage rate, so R over 100, by what is owing. We call that the balance. So the interest that's charged, 0.375%, so over 100, of $74,000. So if we have a look at that, we get $277.50. She is charged $277.50 for the fortnight because she owes so much at this point, $74,000, and that is our rate per fortnight. Now this can be done another way, so we'll just separate this into two, because what you could have done was multiply by our capital R value to get what is owing after that point. So that's added on the interest. But then to get what the interest is alone, I need to take that value and subtract what she started with. So this is what's owing after interest is added. Take away that principal, the interest is left, $277.50. I like the way on the left because I think it's a lot faster. Less calculations here, of course. And the part on the left just demonstrates you have a really solid grasp on what's going on here, in that you are being charged interest before a payment is made, and it's interest charged on the balance that you owe. This last part, again, is just getting us to explore what's happening payment by payment. The principal repaid is what we're trying to find. So in other words, how much has been paid off the loan? Because she's paid back, obviously, $323.73 with the first repayment, but some of that's gone to interest. In fact, a lot of it's gone to interest because we just found the interest down here. So I'm really looking at some key things here. I'm looking at what she's paid. She pays $323.73, but she was charged $277.50 in interest. And so in terms of what comes off the loan, she gives the bank back this amount, but they subtract this amount here in interest, that's the charge for borrowing that money. So the principal repaid, in other words, the amount she's paid off, we're going to see is very small, which is a little bit unsettling when you are paying back a really big loan like this one. She's paid back this, but this much was interest, and so she's only paid off $46.23 off of her loan. Now, keep in mind this is quite a big interest rate. She has borrowed a lot of money as well, so $74,000. Where we're headed with this is, what you're going to see is when you borrow a lot of money, so something like $74,000, or maybe something like a mortgage, you might be borrowing more like $400,000, you're going to see that the amount that you pay off of that loan at the beginning of the loan is minuscule. It's so tiny. And that's what I was saying before about it being a little disheartening. When you are paying off this big loan, majority of what you're paying is actually going to the interest. So you're not really making much ground on your loan until later in the loan. We're going to see that happen with the amortization table. That's going to show it more clearly for us. And so I'll stop this video here so that you can practice just with the recurrence relations at this point before moving on to having a look at some of these more substantial loans.